Welcome back to IM1. Today's topic 3.2.1, how can algebra tiles help me multiply? So how we'll be able to, today I will be able to identify dimensions and compute the areas and perimeters of shapes formed with algebra tiles. So we're going to be looking at modeling area and perimeter using the algebra tiles. Again, the main objective today is for you guys to distinguish the difference between what is area and what is perimeter, all right? So let's look at the first question right there, 373. It says the dimensions of the algebra tiles are shown. It writes the algebra tiles will be named according to each of the areas. The tiles will have a positive side and a negative side. In this text, the positive side will be the shaded side. So for each of the composite polygons formed by the algebra tiles below, use the algebra tiles to build a polygon. So I'm going to put pretty much a link right now so you guys can have the opportunity to check it out, which is this one. So we're going to sketch our polygon on our paper. So if you guys don't have the notes, if you're not able to print them out, again, you can use a notebook so you can keep track of your notes. Make sure you label them on the top, right? 3.2.1, today's date. And also make sure that you guys are including pretty much the shape, right? So that's the shape that you're looking at. And then we're going to label each tile on our sketch with its area, write a simplified expression that represents the total area of the polygon. And then finally, question C, it says write a simplified expression that represents the total outside perimeter. All right, so the first one has y squared. So that would be the area of that. This is x squared. And then this one has an area of 1. So this would be a 1 square unit. All right. So again, if you guys have the notes, you're going to see these at the bottom. So let's first look at the area, right? So let's look at the area of the first shape right here at the bottom. So this one has y squared right here. So again, if you guys were to like put a carpet in a room, you would be looking at the area, right? So that's the area of this, how many square feet I would need, right? So the area is equal to y squared, because we only have one of those. And then plus, right, the area for this one, which is x squared, right? So the entire area for this is x squared. And then finally, the little square, we said that was 1 square unit, right? So 1 square unit plus 1. So that would be pretty much represent the area of the first shape, right? In part C. Okay. And then let's look at the area for question 2, and then we'll do the perimeters for both as well, right? So let's look at the area. And again, now in this case, we do have different shapes. So if you guys notice here, we have XY is this one. So that would be the area of it. We only have one of those. And then this one has a length of Y, right? So this one has a length of Y. So we have how many of those? 1, 2, 3. All right. So plus 3Y. And then the final one, which is just this rectangle right here, which has an area of 1. So we just plus 1x. Sorry, 1x. All right. And now we're going to look at the perimeter, right? So the perimeter would be pretty much thinking about, so the area is how much carpet I would need to completely like cover a room, right? Cover the floor of a room. The perimeter, you want to think about it like how much fencing would I need, right? How much do I need to put up to protect this area, right? So let's say, I don't know, you were building a fence in the backyard. You pretty much, you had to figure out the perimeter of your shape, right? So it doesn't really matter. So as long as you guys know what you're measuring, then you should be fine. Okay. So here we have one side, another side, right? So we want to figure out how much fencing I would need to cover this entire place right here. So for the first square, right, the y square, the big one. So the length of this side, this would be y. This would also be y, right? So again, the area is y times y. So that's why you get y squared. And then on top, we also have y, right? So that's at least 3y right there. And then this part right here, from here to here is x. And then from here to here is also x. And then this chunk right here is 1. This is 1. This is 1. And then this, I would say, is x minus 1. It looks complicated, but don't worry. We're going to figure it out right now. And then this is y minus x right here, this entire side. Okay? So now that little chunking looks a little bit complicated, but actually it's a lot easier, right, than what it looks. So here, the perimeter, so let's start adding what we have already, right, what we know for sure we have. So I'm going to start off with the 3y's, 1, 2, 3, okay? So I know for sure I have 3y's. So here, if you guys notice the length of this part right here, and then this entire chunk plus this chunk, like all the way from here to here, the x plus 1, and then this, the y minus x, is equal to pretty much just y, right? Because if you guys notice, that's the width of our rectangle right there. So I have another y right there. So that takes care of this, and of that, okay? And then the bottom part right here, we have x minus 1 plus 1, right? So if we add those together, plus 1, you notice it's just equal to x. So that's the nice thing about it. This entire length right here is just x. So plus 2x. And then the only one we just need to consider and not forget is this little side right here. So that would be just plus 1. So the perimeter would be 3y, combine the like terms, right? 4y plus 2x plus 1. And then looking at part 2, so same thing, right? So this one has a length of x. Now these right here, the rectangles, the skinny rectangles, have a width of 1. This one has a width of 1. This one has a x. There's an x here. This entire side again, let's look at it. So it would be, this is y, this is x. So this would be pretty much y minus 1. All right. So the perimeter, let's again write it out, right? So we have all the parts together now. So we have y, and then x plus 3, x plus 3, and then y minus 1 plus y minus 1 plus x plus 1, and then plus x again, which is this one, and then plus 3 plus x, plus 3 plus x. All right. So those are all the sides pretty much that are there. Let's simplify. Let's look for all those like terms. So this is going to be, there's 1y right there, 2y. So 2y. And then 1x, 2x, 3x, 4x. So plus 4x. And then 3 minus 1 is 2. Plus 1 is 3 again. Plus 3 is 6. And that would be pretty much the perimeter for this shape.